So today we've come to Shotton. Now often when people visit the steelworks they will watch the steel as it goes through the lines. But often you miss the science behind the steel. And today we've come to number 6 galvanising line to see some of the work that's gone on to upgrade and replace some of the hydraulic systems in the coiler entry part of the system. And delighted to be joined by Jason Davies. Jason, Senior Projects Engineer here. Jason, tell me when this project all started and what was the rationale for it?
The rationale was really the existing equipment is original, 1980s vintage. So going back as far now as late 21, we did a feasibility study to look at whether we could secure funding for a new system. Initially that was done on a basis of 10 pence per kilowatt hour when we were looking for energy efficiency and savings, financial savings. Soon we realised that the price of electric had increased and it was then 20 pence per kilowatt hour, and now we're paying nearer to 30. So the savings have been multiplied by 3 times already.
Yeah, so we talked then about the sort of essential replacement of ageing kit, but you quite quickly started talking about the energy cost savings. Now people might say, listen, you're just replacing one pump with another, how do you get any energy savings out of that? It's quite a complex setup, isn't it?
Yeah, the existing setup, it's a big ring main circuit, so the same HPU feeds the whole of the entry section. There's 4 motors and pumps, 40 kilowatt motors, and they're just constantly at full power, whether anything's being used, whether the demand's there or not. So the new system relies on 37 kilowatt motors, but they're inverter driven, synchronous reluctance motors, IE5, so the state of the art, the best energy efficiency motors you can get on the market today.
Yeah, so when they're not needed for the hydraulic pressure to move the parts on the line, they just back off, I guess, don't they? Yeah. And when we've just been on the line, haven't we? And we've seen opened our eyes, or mine certainly, about how many moving parts there are on a steel rolling mill, a galvanising mill like this. Because I guess pretty much most, if not every, moving part on the line is hydraulically driven. Would that be true? Yeah,
the majority are hydraulic. There's obviously pneumatically driven equipment as well, but the majority, the high pressure equipment, is all hydraulic. So what we do, we feed into the accumulator bottle system, which is stored pressure, and as the demand increases, then they deliver to the line, and then they're eventually just topped up by the motors.
Yeah, and you mentioned about the cost of energy and how important that is becoming, but of course also our environmental profile. And here, Shotton, you got the sustainability commitment, and I'm sure that plays a big part of it as well. Yeah. But I guess it costs a lot to maintain old equipment. So is there some sort of maintenance cost and reliability benefits of this new setup?
Certainly reliability as well, yeah, because there's a lot of monitoring on this new equipment, pressure flow, particle monitoring, so hopefully you're able to anticipate any problems before they happen.
Yeah, and more that's the case. And I know I've been to Shotton before and seen lots of these monitors, and we've just been in the pulpit with the guys in the pulpit, and the amount of data they're going to have is even more than they've currently got, and they've got a lot.
Yeah, that's correct, yeah. They'll have full visibility, and you can access that from anywhere.
And before we finish, Jason, while we're in this building, because this is a new building to house these hydraulic motors and stuff, the building's quite special as well. Tell me a bit about the building.
The panel system that we're using, the wall panels are a Trima panel, they're 70mm insulated panels, and the roof space is 100mm Trisomet system.
But this is quite special on the outside, isn't it? It's got some special coating because it is a hot day out there, right? You can take my word for it, it's hot out there. It is quite cool in here.
Yeah, so hopefully then that will reflect the heat, and in turn it'll make it more energy efficient. So
we talked about the wall systems and the roof system, but you've got some more sort of environmental benefits to be attached to this building, haven't you?
Yeah, we have. On top of the urban seam roof system, next week we're installing a 14 kilowatt solar array. The building's perfectly south-facing, so we anticipate that we'll get between 12 and 14 kilowatts of energy.
Now, I can't keep you too much longer, but this isn't quite in play yet, is it? How long before this is active and up and running?
There's currently still installation going on, and we'll be tying in. We'll be replacing the original equipment the first week in August during the Gal shutdown.
It's another investment that, it costs a bit of money, but the payback is pretty quick. The payback in terms of reliability of the line, the cost of energy, the sustainability of this part of the business. And, while lots of the stories we talk to you about are about these big pieces of kit and multi-million pounds of investment, we should not forget that every part of a steel industry has what Jason described to me earlier as the arteries of the system, the hydraulics that make everything move within a steel mill and make it operate. And this is another great example of a relatively small investment with a quick payback time that's going to make a huge difference to this part of the line. So listen, Jason, thanks very much for joining us, and good luck with the installation.
Yeah, thank you. Thanks for your time.